When a snowflake falls, it seems like the briefest of moments. Here, then gone, melted on a mitten or absorbed into the ground. But what if I told you that every snowflake has the potential to last far longer than a single winter? Some snowflakes, once they settle, are compressed, layered, and locked away into ice that can survive for hundreds, thousands, even hundreds of thousands of years. Snow is not just weather, it is history in motion. We are going to explore how snowflakes become time capsules, preserving the story of Earth's climate across the ages. To begin, let's picture a snowfall on a remote glacier in Greenland or Antarctica. The snowflakes drift down like they do everywhere else, shaped by the air, fragile, crystalline, but instead of melting in spring, these snowflakes accumulate. One storm is covered by the next, until the weight of the snow begins to compress the layers beneath. Over decades and centuries, this snow slowly transforms into ice. Between the crystals and in the tiny bubbles of air are perfect snapshots of what Earth's atmosphere was like when those snowflakes first fell. Scientists call this record paleoclimate data, and it is one of the most powerful tools we have for understanding the planet's past. Imagine drilling down into a glacier. With every meter of ice you extract, you are traveling backward in time. The snow at the surface might just be a year or two old. 100 meters down, you might be holding snow from the Middle Ages. A kilometer down, you could be touching snowflakes that fell before humans built their first cities. And deeper still, you could be looking at crystals that formed during the last ice age, more than 100,000 years ago. One of the most remarkable aspects of this record lies in the tiny bubbles of air trapped between snow crystals. As snow compresses into firn and then into solid ice, it seals pockets of atmosphere inside. These bubbles contain ancient air, literally the breath of past climates. By analyzing them, scientists can measure how much carbon dioxide, methane, and other greenhouse gases were present at different times in history. It's like having a time machine that lets us sample the atmosphere of the Earth as it was long before we were here. For example, cores from Antarctica reveal that during the last ice age, carbon dioxide levels were around 180 parts per million, much lower than the 420 parts per million we measure today. By aligning these gas measurements with evidence of global temperature changes, scientists can see the direct connection between greenhouse gases and climate. Snowflakes transformed into ice are what makes this kind of understanding possible. They are the paper and ink of Earth's climate journal. But gases aren't the only story written in snow. Each layer of snowfall carries chemical fingerprints of the environment. Volcanic eruptions leave behind ash and sulfur compounds. Wildfires deposit traces of soot. Even solar activity can be detected because cosmic rays affect the isotopes that form in the atmosphere and eventually settle with the snow. Consider the eruption of Mount Tambora in 1815, one of the largest volcanic events in record history. The following year became known as the year without a summer. Crops failed, famine spread, and the skies dimmed with ash. You can read this event not just in old diaries and history books, but in the ice of Greenland and Antarctica. Layers from that year carry the distinct chemical fingerprint of Tambora's eruption, frozen in place for scientists to study 200 years later. Without those snowflakes compressed into ice, our understanding of such events would be incomplete. Ice cores also tell us about the rhythm of Earth's ice ages. By studying oxygen isotopes in the ice, scientists can infer past temperatures with incredible accuracy. What we've learned is that Earth's climate has swung dramatically over time. Glacial periods lasting tens of thousands of years erupted by shorter, warmer interglacial periods. Today, we live in one of those warmer intervals, and the rapid rise in greenhouse gases over the past century stands out in stark contrast to the slow natural cycles recorded by snowflakes over millennia. It's humbling to realize that something as fragile as a snowflake can carry the weight of so much knowledge. Each snowflake, with its lattice of ice and trapped air, is like a micro-archive. On its own, it tells us very little, but billions of them layered together form a continuous, unbroken history of the sky, the air, and the world as it was. This is why drilling and analyzing ice cores is one of the most valuable scientific endeavors of our time. But there's another side to the story. These time capsules are not permanent. As our climate warms, glaciers are retreating at alarming rates. Ice sheets in Greenland and Antarctica are melting more quickly than ever before. That means snow that once would have been locked away for tens of thousands of years is now disappearing into the sea. In some places, the archive is vanishing faster than we can study it. Scientists are racing to extract cores and analyze them before this irreplaceable record is lost. The urgency is not just scientific, it is existential. Without these records, we lose the most detailed story we have of how Earth's climate works. And yet, the story snow tells is not just about crisis, it is also about continuity. Think about this. When you watch a snowstorm, you are watching the very process that builds these archives. It's unfolding in real time. The snowflakes drifting past your window, they may melt tomorrow, but on a glacier. Snowflakes just like them will one day become part of a record that future generations will use to understand us. Snow connects the present to the past and the past to the future in a chain of crystalline memory. There is something profoundly poetic about that. Snowflakes are so transcendent and delicate. They're also the most enduring storytellers we have. They have recorded ice ages, warm periods, volcanic winters, and now the age of human industry. They are unbiased witnesses. They don't exaggerate or omit. They simply fall, layer upon layer, until we learn how to listen to what they've been keeping all along. So the next time snow begins to fall, try to see it not only as weather, but as history in motion. Imagine each snowflake as a potential messenger to the future, carrying with it a tiny sample of today's air, today's chemistry, today's sky. Think of glaciers not as static ice, but as vast libraries of snowflakes, stacked and preserved, waiting for us to read. And remember that when scientists drill into ice and pull up a core, what they are really doing is opening a book that nature has been writing. Snow is fleeting, but the stories it tells are eternal. When we analyze the air, the isotopes, the fingerprints of fire and ash, we are holding the memory of the planet itself. Snowflakes are more than frozen water. They are frozen time.